right. All right, and write the zeros of g of x. Of course, my zeros are +7 and +2. Looking at this from the beginning, before I knew how to factor it, would I have considered that x equals 5 as a possible zero? I'm getting a no. I'm getting a no. I definitely agree with that no. Seeing as I'm recording it on mine, I should probably pin my particular sheet. No. Okay, so I got a no. Does someone want to vocalize why they think not? Yeah, Nikhil, go ahead.
I mean, I can't really explain it. It's just like it doesn't look like it.
It doesn't look like it. Okay, so these numbers kind of look like something.
Five
Well,
doesn't go into 9 or 14. It doesn't like add up to them. It doesn't do anything. So
okay, does it have to go into 9?
no.
Okay, but does it need to go into 14?
Yeah.
All right, and that's really the issue here. That 5 in no way, shape, or form is going to multiply up to 14 unless we got something really, really bizarre going on and irrational answers, which is a possibility. Sometimes that's going to happen. But no, that's not a possibility. No, 14 is not divisible by 5. Use the most efficient method to find the roots of this guy. What the most efficient method is, aside from graphing it on a Desmos, that's kind of an odd thing to say. Hi, we can try to factor it. If it is factorable, that is very efficient. So let's see. Things which multiply together to get 10x squared could be a 10x and an x, but it's usually more likely the ones closer to the middle. So I'm going to try first a 5x and a 2x. Things which multiply together to get 18, again, they could be a 1 and an 18, but they're usually closer to the middle, such as a 3 and a 6. If I put the 6 over here, it's going to be multiplied by the 5. That seems unlikely. So I'm going to put the 6 over here and the 3 over here. The 6 times 2 is 12. The 5x times 3 is 15. They are 3 apart from one another. This is looking good. The bigger one should be positive. The bigger one is not because 5 is bigger than 2. It is because 5 times 3 is bigger than 2 times 6. And that seemed to work. Look at those roots. Those are some interesting ones. 6 fifths and -3 halves. Huh. Interesting. Those numerators are both factors of 18, but 5 isn't. The denominators are factors of 10. Dun, dun, dun. Yes, is the correct response there. All right, so let's figure out what the rational zeros theorem says. If f is a polynomial function with integral coefficients, in other words, those coefficients are all integers. Nothing says like 1/2 x or anything. And if p over q is a factor of f, I guess a 0 of f, then p is a factor of, okay, yeah. is I'm going to go with 0 of f. I think that's. Then p is a factor of the constant term. We call the last term the constant term because regardless of what x is, negative 18 stays the same. If x changes, then 3x changes, 10x squared changes, any other term would. And of f of x, and q is a factor of the lead coefficient of f of x. Okay, so back over here, now we've got at least some ideas on that previous page, like the p's over q's, which we will call the possible rational roots. Not that there aren't irrational roots, would be plus or minus the factors of 8, which are 1, 2, 4, and 8 over the factors of 3, which would be 1 and 3. And that's a nice shorthand way of writing all of them. By the way, should I put a plus or minus on the bottom because 3 also factors could be plus or minus 3? Yes or no? What do we think? Should I put a plus or minus on the bottom? The factors of 3 are really plus or minus 3. It could be -1 and -3. I got a thumbs up. Well, do I really need both? Since one of my numbers will be positive 1/1 and one of them will be -1/1, if I put another plus or minus on the bottom, then I got +1 positive once and +1 negative once and -1 positive once and -1 negative once. And that's a whole lot of redundancy. So it's not wrong to do it, but we certainly don't need to. How are we doing on time? Oh, we're doing nice. Okay, so back to number 7. Let's take a look at those possible rational roots. And again, these aren't all the possible roots, they're just the possible rational roots. Those would be plus or minus 1 or 3, technically over 1, and I'll write it, but that didn't really change anything. I never use synthetic division to check 1 because it's so much easier just to add up all the coefficients. 1 minus 7 is -6, plus 11 is +5, plus 3 is 8. Okay. So now I've only got 3 other things that I could possibly check. -1 is probably easy enough to plug in by hand. Yeah, Nikhil, what's up?
Wait, why did you just the coefficients?
Why did I what now?
You just added all the coefficients, right?
Yes, that is what f of 1 would be. Because no matter if x is 1, then I don't care if I'm squaring x or cubing x or raising it to the 59th power. It's still 1. So f of 1 is 1 minus 7 plus 11 and plus 3. The only thing negative was that 7, and that's not as big as everything else. F of -1, again, if you want to use synthetic division, be my guest, but it's pretty straightforward. It is going to be a -1, a -7, a -11, and a +3. Kind of has the same issue there, that so many things are negative. The only thing which is positive is 3. It's not going to end up being 0. Ethan, what's up?
Why isn't it +7?
Why isn't it +7? Because what is -1 squared?
Oh, okay.
See, today I'm on it. Yesterday, not so much. But, all right, 3. Oh, man, I don't want to cube 3. That seems ridiculous. I am going to use my balcony. So to check for whether 3 is a 0, I'm really dividing out by x minus 3. So I'm putting a +3 in the balcony. And those coefficients are 1x to the 3rd negative 7x squared, positive 11x, and 3. And here go my 2 steps. 1 plus that is still 1. Multiply, and I get a 3. Add, I get a negative 4. Multiply, I get a negative 12. That's looking pretty promising. Add, I get a negative 1. And how about that? Woo! Very, very happy. Once again, that's a picture of me. Find all zeros. I just found 1. The other zeros really f of x equals x minus 3 times x squared minus 4x minus 1. Clearly that is unfactorable, but it's not that it doesn't have any zeros. It's just that I'm going to have to use quadratic formula. So my zeros are positive 3, negative 4 plus or minus the square root of 16 minus a negative 4, so the square root of 20, all over 2. I can do a little bit of stuff with the square root of 20, so I'll just say that's negative 4 plus or minus 2 root 5 over 2, and eventually that gets to be negative 2 plus or minus root 5. So, sorry, I kind of wrote big and didn't leave myself a ton of room there, but there we go. Nikhil, you have a hand up.
Okay, sorry for all the questions, but
No, are you
one thing
kidding?
I don't understand. So I get like how you got the P over Q and all that stuff, but why did you plug in like the p-values, potential p-values for x?
Because these are my possible rational roots, and these aren't the p-values. These are the p over q, because it's just over 1. So these are my possible rational roots. I wanted to find which ones of them work.
Okay, so let's say the bottom was 2.
Yes.
Would you just plug in like 1/2 and then negative
Yes.
1/2? And okay.
Yes, indeed.
Okay.
100%. You are totally on it. Okay. Let's see. Find all x-intercepts. Another way of saying the same stuff. We are clearly not going to get through a whole lot of this stuff in the next 7 minutes or so. But let's at least see if we can start this one and figure it out. So my p-values are 1 and 2, technically plus or minus. My q-values are 1 and 3. Again, technically plus or minus, but it doesn't make any sense to do that. All right, so my smallest one is plus or minus 1/3. Then I have, I guess, 2/3, 1, and is that it? And 2, haha. One was staring at me in the face. I always try 1 first because it's super easy, and I always just do it by hand. 3 minus 1 minus 15 minus 1 plus 2. Does that seem likely to you? And I don't have to add those numbers up together to realize that they do not equal 0. There's a negative 15, a negative 1, another negative 1. Those are all my negatives. And my only positives are a 3 and a 2? No, not so much. All right. Which number do you want to try now? I got 2. All right. Sure, we can do 2. Should we do it by hand, or do you want to do it? Those look like gnarly numbers. Let's do it the way we're supposed to. 2. We'll get a 3, a negative 1, a negative 15, a negative 1, and a positive 2. Here goes. 3, 6, 5, 10, -5, -10, -11, -22, and wow. Looks like a -20. Did I do that one right? 3, 6, 5, 10. Yeah, looks good to me. Okay, this is a good try. Nothing wrong with that. You are not doing this wrong if you don't find the answer right away. It's not a. What number do you want to try next? Was that 2/3? Okay, 2/3. Sure. Let's do it. 2/3 in the balcony. There is a 3, a -1, a -15, a -1, and a +2. 3 is 3. 2/3 of 3 is 2. Subtract, I get 1. Multiply, I get a headache. 2/3. Add, I get. Does anyone think that this is going to work? I don't either. And again, that wasn't a wrong thing to say. Try 2/3. Of course, you can try 2/3. Just because it didn't get there, it's not a bad thing. All right. The only positive one we haven't tried yet is 1/3. Let's do that. 1/3 in the balcony. 3, -1, -15, -1 again, and +2. Here we go. 3 plus nothing is 3. 1/3 of 3 is 1. Add them, I get 0. Multiply, I get 0. Add them, I get -15. Multiply them, I get -5. Add them, I get -6. Multiply them, I get -2. And whew. So good news, we found one. Bad news, we're only down to a cubic. So still, I can't do quadratic formula on a cubic. But, Ethan, you have your hand up.
Is there a way to make an educated guess on what?
Yes, there are lots of ways to make educated guesses. Before we make educated guesses, I need to educate you on a few more things. It's not all going to happen in one lesson. Yes, indeed, we can certainly streamline this process a fair amount. In fact, there's a bunch of theorems: upper bounds, lower bounds, de Moivre's law of sines, intermediate value theorem, all kinds of crazy things. So I love it. By the way, our new thing, which we're now factoring, so we're going to factor from here from now on, has a final term of 6 and a leading term of 3. We aren't going to try 6, even though that is now part of the P's over Q's, because it wasn't part of the original ones. It just wouldn't make any sense. Is it possible that 1/3 works a second time? That it's a factor of multiplicity more than 1? Sure, that's a possibility. I don't know. And all these numbers are nicely divisible by 3. That kind of sounds almost likely. I don't know. Yes, I am not going to go any further on this today for a variety of reasons. 1, I have run out of space. 2, I have run out of time. But we will pick up here again, not tomorrow, seeing as we X. Yay. Not the day after that, because that is a legitimate Saturday.